Hello everyone, I welcome you all to the Infinity Vision platform. I am Chandan Sharma and right now I'll be discussing some of the very important formulas of your class 9th physics as far as NTSE stage 1 is concerned. So अगर NTSE stage 1 की बात करें तो आपके जितने भी चैप्टर्स हैं क्लास 9th के मोशन, बीट योर वर्क एनर्जी, बीट योर लॉज ऑफ मोशन और आपका साउंड चैप्टर, ऑल्दो साउंड चैप्टर आपका CBSE से डिलीटेड पोर्शन है बट स्टिल योर NTSE एग्जामिनेशन में स्टेज 1 में आता है. सो विल बी डिस्कसिंग दोज फॉर्मुलाज विच इज रिलेटेड टू साउंड चैप्टर ऑल्सो. Okay, so let us begin with the very important formulas of motion chapter first. तो सबसे पहले motion chapter में से कौन कौन से formulas हैं और जो numerical formulas हैं जो आपको learn करने हैं so that you can easily excel in your NTSE stage 1 examination as far as physics is concerned. Okay, the first formula is जो कि आपको learn करना चाहिए, that is average velocity. So the average velocity is nothing but total displacement by total time taken. Okay, again अगर throughout the journey है, suppose if a body is moving so the body, if it is moving from one point to another, so how its average velocity can be easily calculated as, suppose if a body is moving from A to B and B to C. Okay, so the total distance is x and let this distance is x1 and let this distance is x2. Okay, so the average velocity is nothing but total displacement, which is x1 plus x2 divided by total time taken. Suppose t1 is the time taken to move from A to B and t2 is the time taken to move from B to C, so it would be t1 plus t2 and so on. You can easily find out using this relationship. Average velocity is total displacement by total time. Okay, we'll be moving to the next formula now. The next formula is this one, average speed. Again, average speed is nothing but total distance moved by total time taken, because it is a speed, so that means it has to be total distance by total time taken. Okay, if when an object travels different distance with different time. Okay, so that means if a body travels s1 distance in t1 time, s2 distance in t2 time and so on, s3 distance in t3 time. So what is total speed? Total speed is total distance by total time. Total distance is s1 plus s2 plus s3 and total time is t1 plus t2 and t3 and so on. You can easily find out the average speed using this formula. You must remember such formulas because the question may directly come into the examination and you can use this relation and find out the answer very quickly. Okay, so we'll be moving to the next portion of your motion chapter. Which formula is important? This one is also important. Average speed is when object travels different speed in different time of interval. So that means if the time is different, okay, and a body travels t1 in t1 time, it is traveling with the speed of v1. In t2 time, it is traveling with the speed of v2 and so on. Okay, so the total distance is nothing but distance during this motion is distance equal to speed into time, so it would be, and s2 must be equal to speed into v2 into t2 and so on. So it would be, so the average speed would be total distance by total time. Total distance is v1 t1 plus v2 t2 and so on, divided by total time is t1 plus t2 and t3 and so on. Okay, this is also quite easy. You can easily directly use this equation. We'll be moving to the next important formulas. Okay, as far as class 9th is concerned, the next important formula is average acceleration. Average acceleration is again is nothing but total change in velocity by total time taken. Okay, total change in velocity. Suppose a body is moving with certain velocity. Okay, and it has been subjected to acceleration. So its speed is keep on increasing. So you can easily find out what is the average acceleration. Average acceleration is nothing but change in velocity. Final velocity minus initial velocity per unit time taken. Okay. So the next important formula that you must remember is the equation of motion. Okay, so this is the most important formula of your laws of motion chapter. So you have three equation of motion over here, which is v is equal to u plus at, where v is final speed, u is initial speed of a object, a is the acceleration and t is the time taken. Okay, so if a body is having certain speed u and it is subjected to a force, so that means it will gonna accelerate with certain acceleration a, and this acceleration has to be uniformly accelerated. So that means acceleration is constant. Okay, so that means you have to remember this equation is only applicable when the acceleration is constant. So and finally, because of force, its speed becomes v. Okay, so you can use this relationship v is equal to u plus at, and also you can use this relationship of displacement with respect to initial time and initial velocity and time and acceleration as this one. So suppose s is the displacement taken from moving from u speed to v. So that means this displacement must be equal to s equal to ut plus half a t square. Again, third equation, v square minus u square is equal to 2a s. Again, this is the last equation that you must remember, which is distance traveled in nth second, which is nothing but u plus a by 2 2n minus 1. So nth second means if a body is continuously moving, suppose in 1 second, suppose a body starts from rest, it keeps on moving. In 1 second, its speed become 20 meter per second. Again, in another second, its speed becomes 40 meter per second. Okay, with each second, its speed is increasing by 20 meter per second. Okay, so you can easily find out the distance traveled in nth second. So this is the second. This is the second of a motion. It has completed 1 second. After that, the motion is nothing but second of the motion. Okay, so during the second of the motion, n becomes 2. So during this, you can easily find out this distance, which is s to nth second. Okay, so using this relationship over here, the n must be equal to 2, and initial speed is over here is 0. Okay, likewise you can easily use this equation. Why I'm emphasizing on all these formulas is because you'll be getting you'll be getting numerical out of these questions. Again, if it is accelerated motion, the acceleration has to be positive. If it is decelerated motion, this acceleration would be negative. Again, for such type of question also come for gravitation. So I'll be discussing the gravitation part also here, because it is quite related to that chapter also. So during vertical motion, what you can do is, during vertical motion, we know that suppose u is the speed with which it is thrown, and it will move it to its maximum height at which its speed becomes 0. Again, it will gonna fall down and it will hit the ground with the speed of u only. Okay, at any certain time, suppose t is a time travel, at this point its velocity becomes v. So you can usually use the equation, and acceleration due to gravity a is g over here, which is always directing downward. Okay, so you can easily use this equation as v is equal to u minus gt, because downward direction if you are taking as negative, so the upward direction is taken to be as positive. So in this particular case, the acceleration due to gravity has to be negative. Okay, don't you think? So the equation becomes v is equal to u minus gt for h height. Suppose for after t second it has moved to a height of h, so h must be equal to ut minus half gt square. Okay, v square minus u square is equal to minus 2g h. Okay, again distance traveled in nth second, you can easily find out this using the same equation. It would be g by 2 over here. Distance traveled in nth second, you can easily find out. Okay, I hope you can also use this equation for finding the required value in gravitation chapter also, because these formulas are also applicable in vertical motion in gravitation chapter. Okay, so I need not discuss it again and again in the gravitation chapter, so you must remember this. Or you can easily simply use the equation. While moving up, acceleration due to gravity is negative. While coming down, it is accelerated motion. In this particular case, for half motion, you can take g as positive. That you can also do. Okay, so we'll be moving to the next formula. Okay, not next formula, which is next formula which is there in your laws of motion chapter, because as far as motion is concerned, all the formula, whatever I have discussed, you must remember all those formulas. Okay, apart from formulas, you can also learn about graphs like acceleration time graph, velocity time graph. Okay, area under velocity time graph gives acceleration, that you must remember. Displacement time graph. Okay, slope of this displacement time graph will give you, slope of time displacement time graph will give you velocity time graph. Slope of velocity time graph will give you acceleration time graph. Okay, so here the acceleration is negative and its slope is keep on decreasing, so that's why velocities keep on decreasing. Okay, and velocity is decreasing, so at a constant rate, so its acceleration is negative. You must remember all these things. And area under this velocity time graph also gives displacement. Okay, that you should also remember. Okay, so and also using all these equation, we also know the equation which is acceleration is v minus u by t, using first equation of motion. So if I'll do what multiply a over t, it must be equal to v minus u. Okay, don't you think? So the acceleration, if I'll make a graph of acceleration time, okay, and the area of this acceleration time will give you change in velocity, final velocity minus initial velocity. So if the acceleration time graph comes over here, the area of this graph would give you change in velocity. Likewise, you can use this equation to find out different values. Okay, so in laws of motion chapter also, laws of motion chapter, the most important thing that you need to learn is Newton's second law of motion. So Newton's second law of motion is nothing but, it says force applied is nothing but change in momentum per unit time on the system, or in simple word it is called force is equal to mass into acceleration. So you must remember this relation, this force must be equal to mass into acceleration, and this force is nothing but change in momentum, dp by dt is nothing but, change is nothing but p final minus p initial per unit time taken. Body is moving with certain speed u, finally its speed becomes v, mass is m, its mass is m. So momentum, initial momentum is equal to m into u, final momentum is equal to m into v. Momentum is nothing but product of mass and velocity, so it would be, again it would be mv minus mu divided by t, so it must be equal to m v minus u by t, so it must be equal to mass into acceleration, because change in velocity per unit time is nothing but acceleration. Okay, so you must remember all these things. So Newton's second law of motion. You also you should also remember about Newton's first law of motion. Also you must remember about Newton's third law of motion. So we'll be moving to the next formula that you must remember is total change in momentum is nothing but called impulse. We know the relation. We know that force is nothing but change in momentum p final minus p initial per unit time. The product of F into t is nothing but p final minus p initial. So this is nothing but change in momentum. Okay, so the impulse is, this term is called impulse. Its unit would be Newton second or meter or momentum. Okay, so momentum is nothing but kg meter per second. Okay, so this new term is called momentum, so it would be nothing but change in this impulse is also can be classified as change in momentum or product of force and time. Again, if you have the area, force and time graph is given to you, so again the area of this graph would give you change in momentum. Remember this thing. Okay, so from the formula only you must remember the graph at the same time. Okay, so we'll be moving to the next formula now. The next formula is about law of conservation of momentum. Okay, when no force, external force acts on the system, so if nothing is acting from external, if nothing is acting on the system from external, so that means if no force is acting on the system, or that can also be classified as if no net force is acting on the system, then you can conserve momentum. Whatever the initial momentum of the system is, the final momentum would also be similar. So it's like if you have been given a mass ma, it is moving with the speed of u, it is moving with the speed of ua, mb moving with the speed of ub. So after collision, suppose it collides with it, and after collision ma starts moving with the speed of va and mb starts moving with the speed of vb. So initial momentum is ma plus ub, final ma mb plus ub. So initial momentum is the sum of these two momentums, and final momentum is the sum of ma va plus mb vb. Here it is ub. Okay, you must remember it is ub over here. So this term is ua, not ub. Okay, so ma ua plus mb ub, this is the initial momentum of the system, must be equal to ma va plus mb vb. Okay, you can easily conserve the momentum. If this second body is at rest, so ub must be equal to 0. Okay, don't you think? So you can easily use the equation accordingly. So we'll be moving to the next important aspect of your laws of motion chapter, which is centripetal force. This force only acts whenever a body is in a circular motion. So body, if it is moving in a circular track, if it is moving in a circular track just like this, okay, its mass is m, it is moving with the speed of v, so it will have inward centripetal acceleration of ac, so that means it will have inward centripetal force, and this centripetal force must be equal to mass into centripetal acceleration, so it must be equal to m v square by r, because centripetal acceleration is given by relationship v square by r. So it is the force which will make the body to move in a circular track, okay, so that its direction will keep on changing. Here also the work done by this centripetal force is always 0, because displacement and force always are in perpendicular direction. So the work done during the circular track is also 0, that you also remember. Okay, so this is a force which comes into play whenever the body is moving in a circular track. I hope the concept of circular motion and the concept of centripetal acceleration is known to you. Okay, even if you don't know, you can easily remember this formula. Okay, suppose the body is moving on a thread, so the tension would be developed in the thread. This tension must be equal to m v square by r. So this centripetal force is provided by the tension within the thread. Okay, now we'll be moving to the next aspect of your work and energy power chapter. Okay, you must remember, if work is said to be done when the force produces displacement along the direction of force. So that means in scientific term, the work is only done when the force produces displacement in the direction of force only. And the work done by this force, so the work done by any particular force, suppose a body of m kg has been placed and it is subjected to a force of F. So this work done, and it moves in the direction of force a distance s. So this work done by this force must be equal to Fs cos theta. Okay, where F is the force applied and S is the displacement, and theta is the angle between force and displacement vector. Okay, here it is, angle is 0 degree, so that means this force must be maximum and positive. Okay, so you can use this equation. Force can also be applied over here, so the angle between them is theta. You can easily use this relation to find out the value of work done by that force. Okay, so we'll be moving to the next question, next formula. The important formula is this one. So how a work can be positive, how a work can be negative, and how a work can be 0. If the angle between them is between 0 to 90 degree, so that means if the work, so that means object has been subjected to a force F and it displaces over here in this particular direction. If till the point it is 0, if this angle is 0 or 90 degree, the work is the work done is positive, because cos between 0 to 90 is comes out to be, because cos 0 degree is 1. Okay, you will be getting positive value of the cos from 0 to 90. Okay, so now we must remember till the point it is 0 to 0 to less than 90, 0 to less than 90, till the point the max you will be getting positive work done. Okay, and it is maximum when the angle between them is 0 degree. So when it can be negative, when the angle between them is between 90 degree to greater than 90 degree and between 180 degree. So that means, and in simple word you can say that whenever a force is acting, okay, because cos 180 degree is also -1, so then only you can work has to be negative. Or you can say when the angle between them is greater than 90 degree and less than 180 degree, then the work is said to be negative. Okay, or less than or equal to also. Okay, so that means whenever a force is acting on the body, so force, if it is acting just like this and displacement is in this direction, then the force is said to be negative. Okay, I hope this concept is also clear. Now we'll be moving to the how a work can be 0. Again, when the angle between them is 90 degree, that I already said it to you, during the circular motion, the work done during the work done by the centripetal force is 0. Okay, because the angle between force and displacement is always 90 degree. Okay, so this is about work done, and now the next aspect that you must learn about the work energy chapter is kinetic energy. It is energy possessed by a body by virtue of its motion. So it is given by relationship half m v square, and in the terms of momentum it is given by p square by 2m. Okay, so you must remember this relation because so many times the question comes in the form of p square by 2m. A body having mass m moving with the speed of v having kinetic energy of half m v square. So this kinetic energy is equivalent to p square by 2m also, because how will be how will come to this conclusion? It is equivalent to, we know that this is half mv square. If I'll multiply with m and m over here, so you'll be getting half of mv whole square by m. So this is nothing but half p square by m. Okay, so this kinetic energy comes out to be this. Sometimes they may also ask the relationship between momentum. So the momentum can also be equivalent to 2 m k. K is the kinetic energy of the system. Okay, you can use either this equation, or this equation. Okay, accordingly, if the question comes, you may use this equation as well as this equation. Okay, now the next formula that you must remember is of potential energy. Potential energy is the energy possessed by a body by virtue of its position. Okay, and it is given by m into g into h. Suppose the body moves to a height of h, okay, whose mass is m. So it is over here. So the potential energy possessed by a body is m into g into h, where g is the acceleration due to gravity. Okay, higher it goes, more would be its potential energy. Okay, now the next aspect of this work energy chapter that you must remember is work energy theorem. It says change in kinetic energy must be equal to work done by the net force on the body. So whatever be the net force acting on the body must have a change in kinetic energy of the system. That must produce change in kinetic energy of the system. So how is it possible? If multiple forces F1, F2 and F3 is acting on the body and its initial speed is u. After subjection of the force, its speed becomes v. Okay, so the work done by this force F1, and suppose it has moved a distance of s. So F1 into s, work done by this force F1 into s into cos theta, which is cos 0 degree because displacement is in this direction and F1 is also in this direction, plus work done by F2, which is 0 because displacement is in this direction and the force is acting in the downward, so the angle between them is 90 degree. Work done by F3 is negative because displacement is in opposite direction. So F3 into s must be equal to change in kinetic energy system. So it must be equal to this term, half m v square minus half m u square. So this is all about work energy theorem that you can use accordingly. Okay, this force again can be friction force while it is if it is moving in this particular direction. This could be a friction force. F3 could be a friction force. Here you will put the value of friction over here, which is mu mg in this particular case, mu into n. Okay, now I hope this work energy is clear to you. So next what you can learn about is power. Power is nothing but rate of doing work, okay, or time rate of doing work. So power is nothing but work done per unit time. So, and this is also called instantaneous power, the small power, the power at that instance, force multiplied by change in displacement per unit time. So it can easily calculated as F into V. If a body is moving with V speed and force subjected to a force of F, then its power comes out to be F dot V. Okay. Again, numerous other power have different other units like horsepower. 1 horsepower is 746 watt. Okay, and power is nothing but work done per unit time, which is nothing but energy stored per unit time. So this energy stored is power multiplied by time also. Okay, so if power is 1 kilowatt hour and time is 1 hour, okay, then this 1 kilowatt hour is the unit of energy, not the unit of power, that you must remember. Okay, so this is a unit of energy, not power, and it is equivalent to 3.6 into 10 to the power 6 joule. How come? We know that 1 kilowatt is into 1 hour is nothing but 1000 multiplied by 3600 second. 1 hour is equivalent to 3600 second, and kilowatt is nothing but kilo is nothing but 1000. So it would be 3.6 into 10 raised to power 6 joule. Okay, so these are the things that you must remember as far as your NTSE stage 1 is concerned. So this is all about work done. So we'll be moving to the next chapter, which is gravitation. Okay, gravitation chapter also comes in your examinations, and it has got two portions, gravitation as well as fluid portion. Okay, all the fluid portion has been deleted in CBSE, but it still comes in your stage 1 examination. So it says what the universal law of gravitation says: each and every body within the universe will be attracted towards each other with a force that is called gravitational force, and that force is directly proportional to product of their masses and inversely proportional to square of the distance between them. Suppose you have been given two masses m1 and m2. The center to center separation is r. So this gravitational force, they will be attracted with the force of F magnitude with a force which is nothing but g m1 m2 divided by r square. It is directly proportional to product of their masses and inversely proportional to the square of the distance between them. So that's why it is called as inverse square law, where g is a proportionality constant whose value is 6.67 in 10 to the minus 11 Newton meter square per kg whole square. Okay, so this is the force with which they will, these are the magnitude with which they will be attracted towards each other. More would be the separation between them, less would be the gravitational attraction between them, less would be the gravitational force. More would be the masses of the object, more would be the gravitational force. Okay, what if the distance becomes similar and masses becomes twice? So if m2 becomes twice, m1 becomes twice, and m2 also becomes twice, then the gravitational force comes out to becomes 4 times. Don't you think? This new gravitational force would be 2m2 to m1. Okay, so it would be 2 to 4. So again, it would be 4 times. So numerous times such type of question also comes in your examinations. Okay, keeping the distance same, if masses becomes double, so what would be the ratio of, so what would be the new relation of force? Okay, so the next formula that you must remember is acceleration due to gravity formula. So it says whenever you are on a surface of certain planet whose mass is m and r is the radius of that planet, so the acceleration due to gravity on the planet is given by gm by r square. Okay, where m is the mass of the planet, r is the radius of that planet. Okay, so this is the acceleration with which a certain body on the surface of any planet will be attracted towards, or you can say will have acceleration of this much. If it is Earth, so it would be mass of Earth and it would be radius of Earth whole square. Okay, and it comes out to be, it is close to 9.8 meter per second square. So this is the acceleration due to gravity. You can easily put the values of mass of Earth and g and r over here. So you can easily find out the value of 9.8 meter per second square. Okay. Now, the next topic that you must remember is Kepler's law of planetary motion. This is also most important. It says, first says every planet, first law, it has got 3 laws. It says, first law says every planet revolves around the sun in an elliptical orbit and sun is at its one of the focus. So that means the path of any planet, suppose this is planet, let it be Earth and let this be sun. So its trajectory is elliptical. Okay, with sun at its one of the focus. Its trajectory is elliptical. Okay, so it will move just like this. Okay, and it's with sun at its one of the focus. Second law says the radius vector drawn from the sun to the plane, a planet sweeps out equal area in equal interval of time. So that means if this is a planet, okay, and it moves from here to here in t time. So in another t time, it may move from here to here. So this area and this area is equal. Okay, this area and this area is equal. It can only happen when if it is far away from this sun, then its speed becomes slow. Don't you think? If speed becomes slow, so it will move a shorter distance over here because this area is constant. This area and this area are equal, and in t time it comes over here. In t time it moves from here to here. That can only be possible when here its speed becomes slow. So that means if radius becomes more, so its speed becomes slow. So if it is far away, then its speed becomes slow, and it is nearer to the sun, then its speed increases. So it would be just like this. So the motion would be just like this. Okay. The third law says square of the time period of the motion must be equal to cube of semi-major axis, or you can say in another word, the time period whole square, the time taken to cover the whole path is directly proportional to radius whole cube. Okay, suppose if it is moving in a circular track and t the time taken, r is the radius, so this time taken to move this whole distance by this planet is directly proportional to square of this directly proportional to radius whole cube. That you must remember. Okay, this is all about gravitation. Now we'll be moving to the next portion of the gravitation, which is fluid. In fluid, what is fluid? Fluid is nothing but anything that can flow is called as fluid, like liquid and gas. Okay, and whenever you are there in inside any particular fluid like water, you'll experience a thrust. Okay, and thrust is nothing but a force acting on the body whenever it is placed inside water. Okay, suppose it is inside water, so it will subject it to a force which is perpendicular in direction, and this force is called thrust. Okay, and the pressure inside the liquid is nothing because of the liquid pressure, and liquid pressure is nothing but thrust per unit area. Okay, and it is given by relationship pressure exerted by the liquid column of height h is hg. Okay, h dg. So here it is d. D is the density. Okay, here g is the density of liquid. So that means whenever you are moving downward inside liquid at certain depth h, and d is the density of a liquid, at this particular depth pressure is dgh. You must remember. You will go deep inside the water, then pressure will keep on increasing. Okay, so that means pressure only depends upon depth. Okay, depth and density of that in particular liquid. So next topic that you must remember of the gravitation chapter is the last topic is density is nothing but mass per unit volume, and density of water at 4 degrees centigrade is maximum, and its maximum density is given by 1 × 10⁻³ kg per meter cube. Okay, you must remember the density of water because you have to calculate it in the relative density or specific gravity topic, in which relative densities or specific gravity is given by relationship. It is nothing but the ratio of density of substance to the density of water at 4 degrees centigrade. Okay, so suppose a body having a relative density of 2. So that means its relative density is nothing but density of substance divided by density of water. So density of substance is 2 × density of water. So it would be 2 × 10⁻³ kg per meter cube. So this would be the density of substance whose relative density is 2. Okay. So now the next thing that you must remember is about sound chapter, which is not there in your CBSE course, but it is there in your NTSE stage 1 examination. So that means there are few relations that you must remember is the relationship between the velocity v, wavelength and frequency. Okay, this is frequency, this is velocity, velocity is frequency multiplied by wavelength, that you must remember. Okay, relationship between wavelength, wave velocity. Okay, here it is wave velocity, that you can say it is v. Okay, and this is frequency. Okay, so v is nothing but frequency multiplied by wavelength. So this relation is very important. Sometimes it is also given by relationship v is equal to frequency multiplied by wavelengths. Okay, wavelength is in meter and frequency is in hertz. And you must remember one more thing about the waves is time period is given by 1 by frequency. Okay, so you can easily write it as this time period is also given by 1 by f or 1 by nu. Okay, frequency, this symbol is called nu, or it can also be written as f. Sometimes we write it as nu only. Okay, so this wave speed is in meter per second. It is the frequency is in hertz and wavelength is in meter. Time period is in of the wave or oscillation is in seconds. So we can easily say that 1 second is nothing but 1 upon 1 hertz, don't you think? Okay, because using this relation. Now, the next thing that you must remember about the sound chapter is the time period formula of simple pendulum, which is given by relationship 2 pi root of L by G. Okay, here it is L, so you must keep in mind this relation. So if you have been given a simple pendulum just like this, and this is its mean position, and it is keep on oscillating, it goes there and comes back, again it goes there, and again it comes back to its mean position. So this is these are the extreme position, and L is the length of this simple pendulum, let it be capital L, and acceleration due to gravity is g. So the time period of oscillation is nothing but 2 pi root of L by G. It only depends upon length and acceleration due to gravity of this simple pendulum. Okay, I hope all the concept, all the formulas of 9th is clear to you. As far as your NTSE stage 1 is concerned, you must go through all these formulas and also learn about different graphs that I explained it to you. Okay, and do as much as numerical as well as theoretical question as possible. And the most important thing is you can do previous year questions. Okay, previous year questions and previous so that you can make you could make out at what level you are in right now. Okay, so these the time is limited, so what you can do is go for the previous year questions, and you can also attend our mock test series of your NTSE stage 1 in our organization at the same time. Okay, so I hope as far as 9th is concerned, every aspect of your NTSE stage 1 is okay with you. Okay, so with this I'll end up today's session. Thank you and best of luck for your examination.